Hi everyone, how you doing? Graphing linear inequalities. No laughing. I have an audience today, so if you hear any laughing, although they're here to check to make sure I don't make any mistakes. Alright, graphing linear inequalities. You have the paper we started the other day. This is going to be on the classroom to give you any background in case you need it. It's got the steps on here, but I want to take you through the steps in case you're unsure how to go from the kind of the directions and the sequence to the graphing. So our equation that we're going to, the inequality we're going to graph is y is greater than negative 1/3 x plus 4. The sequence that we have here is first we're going to plot the intercept. We graph it like it's a regular line, almost not even recognizing that the inequality is there. So 1, 2, 3, 4 is our intercept, which is number 1, kind of the y-intercept. Apply the slope to that, and it's negative 1/3, down 1 over 3, down 1 over 3. And so that is our first two, which is something that you learned back in probably middle school, Algebra 1, being able to do that. Our next piece then becomes dotted or solid once we've graphed our line. So the question's going to be in these inequalities is which side of the line makes this true? Because we could have a whole bunch of points that make this true. And the goal is to shade the side where all the points of that shade make this statement true. So step 3 becomes dotted or solid. And at the top of your paper, I've put kind of a key as to whether the line is dotted or solid, which means it includes that line. So if it's a dotted line, that means anything on the line doesn't work. But if it's a solid line, things on the line do work. The way I always remember it is if there's a line underneath the greater than or less than, it becomes a solid line. And in our case, we do not have a or equal to, so it becomes just a dotted line like that. Okay, so we plotted the intercept, that's our y, applied the slope, dotted or solid. One of the little acronyms I've used for this is YSSS, y-intercept, apply the slope, solid or dotted. And then the last part is which side to shade. We don't know which side to shade yet. And what we do is kind of use a test point 0, 0. So the question then is that we have to figure out, does that point 0, 0 make this statement true? And if it's a yes, then we shade that side. But if it's not true, then 0, 0 is not a solution to the inequality. So we substitute that point 0, 0 in for our xy. So 0 is greater than 0 plus 4. 0 is greater than 4. Question is that true or not? It's not true. 0 is not greater than 4. So 0, 0, this side does not fit our solution. And so what we have to do is shade this side. And that becomes our solution to the problem. And you have that graph, we've kind of included that graph onto your paper so it looks similar to this. But those are our 4 points. And the first two should go pretty quickly. The ability to plot the intercept, apply the slope, This shouldn't take too long about dotted or solid, so you should be able to get 3 of the 4 steps done really quickly. And then it's a question of applying the test point and just getting into that habit of plugging X and Y 0, 0 in to see if that side works. Okay, so that covers my lesson based on the paper that's here. So now, in case you need to go back and check it, because this is going to be an important thing of what we have on our midterm come January. So you'll have at least one of these, probably 2 on your mid-year for that. And then during class, I can check on those, and you can ask me some questions as to what you need to have answered. All right, so I'm only doing 1 practice one. I'm not doing more. We'll work on that, the rest of them in class. All right?